Good morning, everybody. Today is 7th December 2020. The day is Monday. My name is Farhan Mazhar, and right now I am in the 10 metric class. And today's task is very simple. We have started revising the concept, and for that purpose, with the help of the knowledge platform, I have created a paper regarding chapter number 18, radioactivity, and we will do this assessment. It's kind of assessment, uh, but we will practice it. Okay. So here we have MCQs. The first MCQ is showing on your screen. I hope you will be able to see it. It says the release of energy by sun is due to the energy which is coming out of the sun. That is due to what? On the sun, remember that thing. On the sun, smaller hydrogen nuclei, they come close to each other and they join with each other and they make a larger nucleus. This process is called nuclear fusion. Due to this reaction, lot of temperature, lot of energy is created. So the source of the energy of the sun is basically nuclear fusion. Okay, where
Okay.
hydrogen and hydrogen, smaller nuclei join to make a larger nucleus. So what's the choice?
B.
B is the right choice. Okay. So let's move to the next question. He says the half-life of carbon 14 in years is this number. I told you, remember this number. You see, this number is asked now, and you should remember this number. The half-life of carbon 14 that is used for carbon dating. I think that number is 5,730 years.
G, sir.
If you have book, we can confirm. I also have the marking scheme. So let's check it from the mark. Yes, 5,730. The half-life of carbon 14 is 5,730 years. So the choice will be D choice. What do you say?
जी सर डी चॉइस ही है.
Okay. The next question on your screen is the half-life of a certain isotope is 1 day. What is the quantity of the isotope after 2 days? Okay. So let me take one of the page so I can show you. Half-life is 1 day. Okay. So how much it will be left after? His question is after. So suppose that thing is n at the start. So after when one half-life has passed, the thing will be how much? It will become n by 2. When another half-life will pass, the thing will further half, and the thing will become, the isotope will remain how much? N by 4. So after 2 days, because the half-life is 1 day, so after 2 days, two half-lives have passed. In the start, if it was n, so after one half-life, it will become n by 2. After another half-life, it will further half, it will become n by 4. So 1 by 4th, 1 by 4th, what we call 1 by 4th quarter, 1 quarter. Okay. So let's see what are the options. He says the half-life of a certain isotope is 1 day. What is the quantity of the isotope after 2 days? We came to know it will be 1 by 4th of the original. 1 by 4th, in English we say 1 quarter. So what's the choice?
बी सर.
B is the right choice. Yes, babe. Yes, that's good. Okay, the next question on your screen. When an element releases alpha particle, what is the effect on the atomic number? Whenever the alpha particle is given out, the atomic number decreases by 2. Remember that. When the alpha particle is given out, the atomic number will decrease by 2. When beta particle is given out, the atomic number will increase by 1. When gamma rays are given out, there is no change in the atomic number. But here he asks a question about the alpha particles. So when the alpha particles are given out, the atomic number decreases by 2. So what's the choice?
C, sir.
C is the right choice. Very good. Okay, so that was section 1. It has 4 MCQs. I have made this paper with the help of the knowledge platform, and I have also assigned this paper on the knowledge platform. And I have also assigned this paper in the Google Classroom as well. So just write these answers, and then we will upload the images of your written work in your homework. Okay. So first question, these are short questions, 2-mark questions. What is meant by background radiation? It's a 2-mark question. What is meant by background radiations? And you have to write it also, okay? So the good thing about I have the answers also. Let me show you. Okay, so I hope on your screen it's visible. So first question is, what is meant by the background radiation? So the answer is radiations present in atmosphere. The one spelling is missing here, okay? Atmosphere due to different radioactive substances are called background radiation. Background radiation is the radiation present around us all the time. So, and that can be due to different reasons. There might be minerals in the soil. There might be rocks around you or underneath the soil. Uh, there might be some nuclear waste dumped in your area, or maybe hundreds of kilometers away from your area. There might be some nuclear bomb testing going on near your area, or maybe thousands of kilometers away. Even from there, the radiation can reach you. Some radiation is coming out of the space, outer space, cosmic rays, we call them. So the background radiation is always present around us. So due to that, the radiation which is present around us all the time, that is called the background radiation. You are supposed to write this answer in your copy. This is the section 2, question number 1, its answer. The question number is 5, sorry. Question number
ठीक
5,
है.
the answer, you are supposed to write it in your copy. And then we'll move to the next question.
Okay, sir.
Hmm, okay. Atomic and nuclear. Okay. The next, should we move to the next question?
Yes, sir.
जी सर.
The next question on your screen, you can see it says, define nuclear transmutation. Define nuclear transmutation. Okay, its answer is not given in the marking scheme, so I am going. Okay. So nuclear transmutation. We have to find the definition. Yeah, here we go. Can you screen this on your screen?
Yes, sir.
जी सर.
The spontaneous process in which a parent unstable nucleide changes into a more stable daughter nucleide with the emission of radiations is called a nuclear transmutation. Kindly write this definition in your copy. I will like to see the images afterwards. Write this in your copy. The spontaneous process in which a parent unstable nucleide changes into a more stable daughter nucleide with the emission of radiation is called nuclear transmutation. When you are done, kindly tell me. Have you written this definition?
जी सर लिख ली है.
Okay, that's good.
Yes, sir.
Let's move. Okay, let's move to the next question. The next question is write two characteristics of gamma rays. Two characteristics of gamma rays. Okay, let's see. Let's see, very easy. Gamma rays are let me here we go. On your screen, this sorry. Can you see this?
ये जो ब्लू कलर का लिखा हुआ है.
Yeah, gamma rays.
ठीक हो
These
गया
are
सर.
the characteristics of gamma rays. Electromagnetic radiations of very short wavelength, their wavelength and energies can vary. High energy gamma rays can penetrate at least one characteristic is they are electromagnetic. The other characteristic is that they can penetrate at least 30 centimeter of lead or 2 kilometer of air. 2 kilometer of air they can penetrate. The you can write these properties. These are the three properties given here. Gamma rays are electromagnetic radiations of very short wavelength. Okay. One characteristic is this, and they can penetrate at least 30 centimeter of lead, and in air they can penetrate up to 2 kilometers. Okay. There are other characteristics also, which are given in the when you are done with the writing your answer, then you can move to the next one. Hmm.
सर लिख लिया.
Okay, okay. So we are going to the next part. You see, here the characteristics of these things were also written in another table. There was a table. I just saw that table. Okay, just forget it. Let's move to the next one. And the next question is question number 8. Write any two characteristics of the gamma rays. This we already done. Describe two properties of gamma radiation. This question we have already done. You see this gamma rays, properties of gamma rays. Because I was selecting the question, so by changing the words, he can give you question, the same question. 8, 7, 8, 9 are the same question. Okay. The next question is question number 8. Define penetrating power. What's the penetrating power? Penetrating power is basically that when you put, for example, alpha particles, beta particles, gamma rays, they are coming out of an object, of a radioactive isotope. So how much they can travel in air, that is the penetration power in air. If they can pass through paper or how thick paper they can pass through, that is their penetrating power. They can pass through the aluminum foil or not, that's the penetrating power. They can pass through lead, they can pass through glass, means how much they can travel in a medium, that is their penetrating. Okay. So what is the penetrating power? The strength of radiations to penetrate a certain material is called penetrating power. Okay. This is the answer. Up till here. Can you see that? On your screen, it's showing, the answer is showing. This first paragraph is your answer, okay?
Okay,
The
sir.
strength of a radiation to penetrate a certain material is called penetrating power. The alpha particles have the shortest range because of its strong interacting or ionizing power. The gamma rays can penetrate a considerable thickness of concrete. It is due to their large speed and neutral nature. The beta radiation strongly interacts with matter due to its charge and has a short range as compared to gamma radiation. The basic definition is in just first two lines. The next lines, if you like, write. If you don't like, don't write.
सर मैंने जवाब लिख लिया.
The strength of what you wrote. You just wrote the first two lines.
जी सर वही लिखी है.
So the definition is that. Okay. But you know, in Sargodha board, we have to write a lot of. Even if a question is of 2 marks, you write a lot. But actually, he asked you only to define what is the penetrating ability or penetrating power. And with that, you can give one example, two examples, if you like.
ठीक हो गया सर.
Okay. Okay. So we can move. Okay. Define nuclear fusion. Okay, we have to define nuclear fusion. Okay, let's find out. Let's use the signs. Nuclear fusion is here. Yeah. It's nuclear fusion. We have to define nuclear fusion. Let me reduce the size. Okay, here we come. You see, the question is define nuclear fusion, okay? Can you see on your screen the definition of the nuclear fusion is showing when two light nuclei combine to form a heavier nucleus, the process is called a nuclear fusion. And you can give the example also. Just write the definition, and you can write this from, then you can write from here. If an atom of deuterium is fused with an atom of tritium, then a helium nucleus or alpha particle is formed as given. You can give this definition. This definition and this example. And you can draw the picture also if you like. You see, when you will be attempting the board paper, you should write, for 2 marks, you should write the definition. And if you make the diagram and the this equation, it will be good. You get full marks. If you only write the definition, I am doubtful that they will give you full marks. So are you writing?
सर डायग्राम बना रही हूँ, बाकी वो इक्वेशन और डेफिनेशन लिख ली है.
Okay, make the diagram. Let me reduce the size. We have to reduce the size.
सर बना ली.
Okay. Write the definition also, okay? When
सर वो
two
भी
light
लिख ली.
nuclei. Okay, and that equation also. You see?
सर वो भी लिख लिया.
Okay, that's good. So let's move to the next question.
ठीक है.
Write 3 isotopes of hydrogen. It's a 2-mark question. Okay? He says write 3 isotopes of hydrogen. Okay, it's a 2-mark question. Okay. 3 isotopes of here we have isotopes. Let me take out now. We have the isotopes of hydrogen has 3 isotopes.
जी सर 3 होते हैं.
Yeah. Protium, deuterium, tritium. Yeah, here we go. Here he has shown. Can you see this blue line? I hope you can see this. Yeah. This is diagram. Okay. Isotopes are atoms of element which have the number of protons but different number of neutrons. In the nuclei, 3 isotopes of hydrogen are shown in the figure. 18.2 protium contains 1 proton in nucleus and 1 electron that revolves around the nucleus. Deuterium contains 1 proton, 1 neutron, and 1 electron. And tritium contains 1 proton, 2 neutrons, and 1 electron. You're supposed to make this diagram also, okay? It's very important if you want to get full 2 marks. Shabash, beta. In your copy, write these definition and explanation, and also draw the diagram. Okay. When you will be done with this, kindly let me know. We can move to the next question. When you are done, kindly let me know.
सर बना लिया.
The diagrams and the text also.
जी सर.
Okay. 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 Let's move to the next question. The next question is we have already done. It says what is meant by the nuclear transmutation. And this question we have already attempted where we said define nuclear transmutation. And he says what is meant by the nuclear transmutation. So nuclear transmutation we have already attempted the question. So let me show you. Nuclear transmutation. Let me show you. You are already done with that thing. Where it went? Live. Analyzing effect. Yeah, here we go. Nuclear transmutation. This is the definition of the nuclear transmutation. You have already attempted this question. The wording was different in that question. In that question, he only said define the nuclear transmutation. And here he's saying that what is meant by the nuclear, what is meant by the nuclear transmutation. So the same question, but the wording, a little bit, the wording has been changed. So it's the same question, okay?
ठीक हो गया.
Okay. So let's move to the next part. Next part is this is section number 3. There are 16 marks, and the first question is of 4 marks, and he says, "What is meant by radioisotopes? Describe their uses in the medicine industry or research." Radioisotopes now this is a long question, okay? So let us see in the book. We have here the topic of radioisotopes. Reduce the size so I can show you where the answer is. For example, okay. Let us first of all select and nuclei which do not emit radiations naturally are called stable nuclei in general. Most of the nuclei with atomic number 1 to 82 are stable nuclei, while the elements whose atomic number is greater than 82 are naturally unstable. They emit different types of radiations all the time and hence continuously change from one type of element to another. The stable and the non-radioactive elements can also be changed into radioactive element of bombarding with the proton, neutron, radioactive isotopes. Okay, this is the answer. Okay, let me increase the size so you can see. From here, from here, the stable and non-radioactive elements can also be changed into a radioactive element by bombarding them with proton, neutrons, or alpha particles. Such artificially produced radioactive elements are called radioactive isotopes or radioisotopes. Here are some examples. Just give one example. This is the first portion of that question where you have to tell what is the radioactive isotope. And then the question is what is, you have to write down some uses. Let me see that. What is meant by the radioisotope? Describe their uses in the medicine, industry, or research. Okay. So you see the, will you like to write this? First of all, write this portion. Okay. The stable. From here, the stable. And the two example, or you can write one example. Will be enough. And the second part of the question is what is their use in the medicine or industry? The stable and non-radioactive elements can also be changed into radioactive elements by bombarding them with protons, neutrons, or alpha particles. Such artificially produced radioactive elements are called radioactive isotopes or radioisotopes. Here are some examples of the production of the radioisotope. So you can give the examples. And once you are done with this, this is the first part of that question. And the second part is their uses in the industry, in the medicine. So we have to first complete this portion and then we'll go to the second portion. Second portion of the question. When you are done with the first part, kindly let me know. You see, here I also have the answer. Beta, can you see this? This answer is coming from the knowledge platform marking key.
ठीक होगा.
In their answer, they say the stable and non-radioactive elements can also be changed into radioactive elements by bombarding them with protons, neutrons, or alpha particles. Such artificially produced radioactive elements are called radioactive isotopes or radioisotopes. Following are some of their uses in the field of medicine, research, and industry. Tracers, they can be used to explore the metabolism of chemical reactions inside the human body, animals, or plants. Carbon dating, it is a method that provides objective age estimates for carbon-based materials that originated from living organisms. An age could be estimated by measuring the amount of carbon-14 present carbon-14 present in the sample and comparing this against an internationally used reference standard. For the medicine, they say radioisotopes are also used in nuclear medicines for curing various diseases. For example, radioactive cobalt 60 is used for curing cancerous tumors and cells. So this answer is also good, and I can also find the answer from the book. Amdia, what do you say? We should write this answer or should we go to the book?
सर ये वाला लिख लेते हैं.
Yeah, this one is good. Okay. This is clearly visible to you?
जी सर.
Okay. It's good. Hamdia, Roshana,
जी
जी
सर।
सर।
Yes, sir.
can we skip the
Yes,
break
sir.
and continue doing this paper? And once we are done with this paper, and then you are free to go. Instead of
ओके
taking break at 10 o'clock,
ओके
ठीक है
सर।
सर, हम स्किप कर देते हैं।
Okay, sir.
okay, we
Okay,
continue
sir.
doing this. And when we are done with this paper, it may take 30 minutes more, and then you are free.
ओके
ओके
सर।
सर।
Okay, so we continue.
Okay, sir.
So, right, once you are done with this answer, kindly let me know. Roshana. Yes. Once you are done, kindly let me know.
ओके सर।
It's a long question, 4 marks. And we are trying that my students get used to write the answers. Roshana, are you with us?
Yes, sir.
You're writing. Yes.
Yes, sir.
Okay. Shabash, shabash. Keep writing. It's very important. You see, we can simply just, I can read the answer to you, I can explain the answer, and that's it. But I believe that writing is very important. Writing the actual answer is very important for your practice.
सर हमने सबमिट भी कराने हैं
Sorry?
सर हमने ये गूगल प्लेटफॉर्म पे सबमिट कराने हैं
Yes, just you're writing this right now. And after this, you just take the photographs of your answers and upload them in the Google Classroom, upload them in the knowledge platform. That's it. And I will mark
Okay,
it.
okay.
We should note the time also, that how much time it's taking to write this 4 marks question. Huh? The answer of this 4-mark question, how much time it's taking.
तो मैंने लिख लिया
Okay,
मैंने भी
okay.
सर
Shabash,
2 per
shabash.
minute
Okay. You have all your time.
सर मैंने भी लिख लिया
Okay, shabash, Zainab. Very good. These questions are, I have taken, this paper I made it on the knowledge platform. And from there we are getting these questions and their answers. And they are from the Sargodha board. These are the questions from the past papers of the Sargodha board. Yeah, I have selected, there was an option that you can select the board. So I selected Sargodha board. So these are questions coming from the past papers of Sargodha board, related with the chapter number 18 of 10 Matric physics.
सर डन
Okay, so very good. So that was a 4-mark question. What is meant by the radioisotopes? Describe their uses in medicine, industry, or research. I hope that you will never forget these answers. Okay, so the next question is it's a 4-mark question on your screen. I hope you can see that. It says write 5 hazards of radiations. Okay. So the radiations can cause, whenever you are exposed to radiation, they are harmful. And if your exposure is more than the specified limit, then you will get a lot of diseases, or you might get radioactive burns, or they might your cells might mutate, and so here he has written the answer is coming. The source is knowledge platform, and I hope you can see that. Yeah, here we go. What's the best position here? Okay. Radiations can also cause considerable damage if not used with precautions. Some of its hazards are radiation burns, which may cause redness and sores on the skin. On the skins, it can damage your skin. Okay. Sterility, inability to produce children. That's the second he has listed. Genetic mutation in both human and plants. Some children are born with serious deformities. Leukemia, cancer of the blood cells. And the fifth one is the blindness or formation of the cataract in the eye. Cataract is that we say motia. In Urdu we say motia. Aankhon mein motia aa gaya. So the blindness or the formation of the cataract in the eye. Okay, hurry up, girls. Write the answer. Write the answer in your copies.
Okay, sir.
You can also find the hazards of radiation in your book, okay? But we are writing the answers which the knowledge platform provided us in their marking. But you can also write the answer from your book directly. You see, the point is that we are not only just giving you the question and the answer. We're not simply discussing them. We are providing the time also in this session that you can write them, because we believe that actually writing the answer is very, very important. Not just discussing the answer, not just reading the answer, but actually writing them on a paper. It's very important. That is the practice which will prepare you for your exam when you actually write the answers.
सर लिख दिया मैंने जिसे मैंने भी लिख दिया
Okay. Zainab and Roshana, are you done?
Yes, sir. Done.
Okay,
Yes,
so let's
sir.
move to the next. Okay, very good, very good. Let's move to the next question. Let me open the question paper first. Okay, the next question on your screen, question number 16. Carbon 14 is a half-life of 5,730 years. How long will it take for the quantity of carbon 14 in a sample to drop to 1/8 of the initial quantity? 1/8. Okay, let me show you. It's very simple. You see, when one half-life has passed, the thing will become half. Another half-life will pass. The thing will become 1/4. And when another half-life would have passed, you see, let me show you here. When another half-life will pass, the thing will become how much? Further, this will become n by 8. So after 3 half-lives, the thing will become how much? 1/8. So how much time has passed? So how much time has passed? 3 half-lives. So the time has passed how much? 3 half-lives. So the time will be equals to, because 3 half-lives have passed, so 3 multiply 5,730. Do you have calculator? Do you
जी
have
सर
Yes,
calculator?
sir.
कैलकुलेट करती हूँ
Okay. So just multiply 3 multiply 5,730. So the total time will be
1,190.
yeah, 17,190 years. So 17,190 years.
जी सर
That is
यही
the
बन
okay. So kindly do this numerically in your copy also. So you see how the knowledge platform do this on your screen. That was our technique, and this is how they do. We know that after 3 half-life cycles, the quantity of carbon-14 will become 1/8. So just multiply 5,730 with 3 and that's 17190 to get the number of years. Okay, so this is how you do this numerical.
तो
But
मैंने दोनों आंसर्स लिखे हैं.
it's a very simple numerical and it is of 4 marks. When you are done with this question, kindly let me know. So we will do the next one. Are you done with this numerical number 16?
नहीं सर थोड़ा सा रहता है
Okay.
सर कर लिया
Okay. So you're done. Zainab, Roshana.
Sir, done.
Okay. So the next question.
सर मैंने भी कर
Sorry,
ली
cobalt 60 is a radioactive element with half-life of 5.25 years. What fraction of the original sample will be left after 26 years? After 26 years. Okay. So let's open a new one. Save. Okay. So how many half-lives have passed? He says the half-life of the cobalt is 5.25 years and after 26 years. So first of all, I will try to find out how many half-lives have passed. So I will number of half-lives, that will be 26 and I will divide it 5.25. You have calculator?
Yes, sir.
So divide 26 with 5.25. See what is the answer. 26 divided by 5.25.
Sir, it is 4.95.
4.95. 4.95. Approximately, this is 5 half-lives. Okay?
Yes, sir.
Approximately how much? 5 half-lives.
5
So let's
half-lives.
see. Okay, let's see what happens. So if we start from here, 1 half-life, 2 half-lives, 3 half-lives, 4 half-life, and then we have the 5th. Okay, suppose here, let me use the blue ink. Suppose that thing was N at the start. Then it will become n. After one half-life, it will become n by 2. When the second half-life will pass, it will become n by
4
4. And then another half-life will pass, and this thing will become how much? N by
by 8.
8. Okay, another half-life will pass, and this thing will become n by 16. And when another half-life will pass, so this thing will become
And by
n by
32.
32. This is our technique to do the question, okay? First of all, we found that in 26 years, how many half-lives will be there? So one half-life is of 5.25 years. So I divided 26 with 5.25. The answer is 4.95 years. So 4.95 half-lives. So that's approximately 5 half-lives. So then we made our grid, and let's say that in the start we have n number of atoms of that isotope. So after 5 half-lives, after one half-life, it will become n by 2, another half-life n by 4, and another half-life n by 8, another half-life n by 16, and another half-life, and it will become n by 32. So this will, how much it will be left? 1 by 32 of the original. So let's see how the knowledge platform gives the answer. Here we have. This is how they write the answer. He says the half-life will complete 4.95 times. That is how they get this answer. 26 divided by 4, 5.25, 4.95. So do you know that we can, how directly we can find? That is 1 by 2. Let me show you that formula. The formula he's using. That is, no. Let me show you on this so I can write. The formula is 1 divided by 2 raised to power small n. Okay, this is the basic formula. So you can do it directly. For example, if 5 half-lives have passed, so you can directly write 1 by 2. So 5 half-lives, so raised to power 5. Okay. So the answer will be, this is another way. Instead of making the grid, you can directly that. If you on your calculator, you do 2 raised to power 5, it will be 1 by 32. But you see, we rounded off 4.95 to 5. But in the marking scheme, they have not rounded it off. So you can do that like this also. So kindly write both the answers. Okay, you should know the technique, both the techniques.
Okay, sir.
Okay, sir.
The difference between their and our is we rounded off 4.95 into 5, but they have not. I will send these files to your. Once you are done with this, kindly let me know.
सर मैंने लिख लिया है.
Okay, that's good. Okay, so that's it, Ji. This was a kind of practice test regarding about the chapter number 18 of 10 Matric Physics, and today we have not just discussed the answers, but we have given time to our students to write them, so they don't have to do homework. So they have time during the class, and they do it, write the answers in front of us. So my dear students, just take the photos of your answers and upload them in the Google Classroom, and also upload them in the knowledge platform. So I will give you marks there, and that will be part of the record. And so that was chapter 18G of 10 metric physics. So I hope that is some to some it is beneficial for you, and it will help you. And whenever my target is now to do these kind of assessments and practice tests on all the chapters of the 10 metric physics. So Ji, thank you very much, and that's it for today. And so have a good day, and thank you very much, and God bless you all.